Welcome to the session on structure of power system. In earlier days, there was a little demand for electrical energy, so that small power stations were built to supply lighting and heating loads. However, the widespread use of electrical energy by modern civilization has necessitated to produce bulk electrical energy economically and efficiently. The increased demand of electrical energy can be met by building big power stations at favorable places where fuel or water energy is available in an abundance. This has shifted the site of power stations to places quite away from the consumer. The electrical energy produced at the power stations has to be supplied to the consumer. There is a large network of conductors between the power station and the consumers. This network can be broadly divided into two parts via transmission and distribution. The conveyance of electrical power from a power station to consumers' premises is known as electrical supply system. An electrical supply system consists of three principal components via the power station, the transmission lines, and the distribution system. Electrical power is produced at the power stations, which are located at favorable places, generally quite away from the consumers. It is then transmitted over large distances to load centers with the help of conductors known as transmission lines. Finally, it is distributed to a large network of small and big consumers through a distribution network. The electric supply system can be broadly classified into DC or AC system, overhead or underground system. Nowadays, three-phase, three-wire AC system is universally adopted for generation and transmission of electrical power as an economical proposition. However, distribution of electrical power is done by three-phase, four-wire AC system. The underground system is more expensive than the overhead system. Therefore, in our country, overhead system is mostly adopted for transmission and distribution of electric power. The image shows the single line diagram of electrical power system. This electrical power system consists of generating station, primary transmission, then receiving station, secondary transmission, substation, primary distribution, and secondary distribution. Generating station. Generating station represents where the electric power is produced by three-phase alternators operating in parallel. The usual generation voltage is 11 kV. For the economy of transmission of electric power, the generator voltage is stepped up to 130 kV, even more up to 600 kV. The transmission of electrical power at high voltages have several advantages, including the saving of conductor material and high transmission efficiency. There is a limit to which this voltage can be increased. It is because increase in transmission voltage introduces insulation problem. Next, we are moving to the topic primary transmission. In the primary transmission, the electrical power at 132 kV is transmitted by a three-phase, three-wire overhead system to the outer skirts of the city. This forms the primary transmission. Secondary transmission. The primary transmission line terminates at the receiving end, that is receiving station RS, which usually lies at the outskirts of the city. At the receiving station, the voltage is reduced to 33 kV by the help of a step-down transformer. From this station, electric power is transmitted at 33 kV by three-phase, three-wire overhead system to various substations located at the strategic points in the city. This forms the secondary transmission. Primary distribution. The secondary transmission line terminates at the substation, where voltage is reduced from 33 kV to 11 kV, three-phase, three-wire. The 11 kV lines run along the important roadsides of the city. This forms the primary distribution. It may be noted that big consumers having a demand more than 50 kW are generally supplied power at 11 kV for further handling with their own substations. Secondary distribution. The electric power from primary distribution line 11 kV is delivered to distribution substations. These substations are located near the consumer's localities and step down the voltage to 400 volt 3-phase 4-wire for secondary distribution. The voltage between any two phases is 400 volt and between any phase and neutral is 230 volt. The single phase residential lighting load is connected between any one phase and neutral, whereas 3-phase 400 volt motor load is connected across 3-phase lines directly. Now let us have a comparison between DC and AC transmission system. Now we go with DC transmission. For some years past, the transmission of electric power by DC has been receiving the active consideration of engineers due to its numerous advantages. The DC transmission have the advantages of it requires only 2 conductors as compared to 3 for AC transmission. There is no inductance, capacitance, phase displacement and surge problem in DC transmission. Due to the absence of inductance, the voltage drop in a DC transmission line is less than the AC line for the same load and sending end voltage. For this reason, a DC transmission line has better voltage regulation. There is no skin effect in DC system. Therefore, the entire cross section of the line conductor is utilized. For the same working voltage, the potential stress on the insulation is less in case of DC system than that in AC system. Therefore, a DC line requires less insulation. A DC line has a less corona loss and reduced interference with communication circuits. The high voltage DC transmission is free from the dielectric losses, particularly in the case of cables. In DC transmission, there are no stability problem and synchronizing difficulties. While going with the AC transmission, it has advantages of the power can be generated at higher voltage levels. The maintenance of AC substation is very easy and cheaper compared to the DC transmission system. The AC voltage can be stepped up or stepped down by transformers with ease and efficiency. This permits to transmit power at high voltages and distribute it at safe potentials. Now we discuss about the disadvantages of AC and DC transmission system. Now we go with the DC transmission system. The disadvantages of the DC transmission system are the electrical power cannot be generated at high DC voltage due to commutation problems. The DC voltage cannot be stepped up for transmission of higher power voltages. The DC switches and circuit breakers have their own limitations. So while going with AC transmission system, the disadvantages are an AC line requires more copper conductor than a DC line. The construction of a AC transmission line is more complicated than a DC transmission line. Due to skin effect in the AC system, the effective resistance of the line is increased. An AC line has the capacitance, therefore there is a continuous loss of power due to charging current even when the line is open.